Hey, so today we're going to be looking at applications of right triangles. And the first thing I would suggest we do is do a little bit of a brain dump. Let's take a look at our sine, cosine, and tangent functions. And you might remember SOHCAHTOA with the SOH meaning sine of the angle theta equals the O, here is the opposite angle, over the hypotenuse. The co under SOHCAHTOA is the cosine of theta equals the adjacent over the hypotenuse. And finally, the tangent of theta equals the opposite over the adjacent. And we can use this all the way through. What we're basically going to be looking for in all these problems is at least two things that we can use. Either we're going to have an angle and a side, or we're going to have two sides to figure out the angle. So let's get started. So imagine, if you will, that you've got some fairly nice surveying equipment, and you have been asked to find the height of a certain flagpole. So you set up your surveying equipment out here someplace. Here's our flagpole. And this survey equipment happens to be set up for 5 feet tall. So there's 5 feet from there to the ground. And you take your surveying equipment and you're able to measure out to the flagpole. And you find that the distance is 35 feet. So from your center point here to the flagpole is 35 feet. Furthermore, you take another sighting. Let's see if I can do this here. You take another sighting from there to the top of the flagpole, and you find that that angle is 40. You find that angle is, and you find that that angle is 40 feet. I'm sorry. And you find that that angle is 40.8 degrees. What is the height of the flagpole? All right, as I just mentioned a couple minutes ago, what we need to do is see if we can find two pieces of this triangle that we have just formed that we can use in our equation. So what do we know? Well, if we're looking for different pieces we can use, we have the 40.8 degrees here, and we have the 35 feet from our adjacent side. How do we know it's the adjacent? Well, from the angle over to here, this would be the opposite side. So we have an angle and we have an adjacent side, and we are trying to measure, right, the opposite side. So we need to find one of our equations that has an angle, the adjacent, and the opposite side. And you'll notice that that tangent function is going to be the part that's going to let us do that. So we have to manipulate our tangent function around a little bit so that we can get that. And you all know how to do that already. So if we have the tangent of theta equals the opposite over the adjacent, and we want to find the opposite side, what do we have to do? Well, we have to multiply both sides by the adjacent, right? That basically cancels this, and our formula becomes the adjacent times the tangent of theta is going to equal the opposite side. So let's see what we can do. Let's pop up the handy dandy calculator. There we go. I'll move it over here. And let's do the tangent of theta first. So I'm going to put in 40.8 degrees. I'm going to go to my trig functions and I'm going to hit tangent. And I'm going to go to 0.863. I'll just keep what we've got here. Never mind. Not going to round yet. Let's use this. And let's multiply that times our adjacent side, which we said was 35 feet. And what did we get? Well, we got 30.21118 looks like. So we can round that off to 30.2 feet. However, what we still have to take into account, that only gets us this part. Remember, we started about 5 feet up, so we've got to actually add an additional 5 feet on here. So what is 30.2 plus 5? Well, the total is going to be 35.2 feet. All right, so let's give another one a try. So this says, from a point on the ground, 255 meters from the base of a tower, the angle of elevation to the top of the tower is 57.6 degrees. Find the height of the tower. So similar to what we just did, but it's a little bit different. So here's our tower. I'll put it out here someplace. And what do we know? Well, we know from some point out here, so from there to there, we have 255 meters. And we also know that from the very top of the tower to here, we form an angle of 57.6 degrees. And we want to know the height of the tower. Well, we already know which equation to use. We just use the tangent function because we have the adjacent side here, 255 meters, and we're trying to find the opposite side out here, given this angle. So we're going to use the tangent function, and we just worked that out. So we know that we need the tangent of theta times the adjacent side, and that's going to give us the opposite side. So let's put in the tangent of theta and see what we get here. So we've got 57.6 degrees is our angle, 57.6. We're going to take the cosine. We're going to take the tangent, and we get 1.575. We're going to multiply that times 255 meters. And we get 401.81 meters. We were only given 3 significant digits, so that's going to round us off to just 402. right, so this one's a little bit different. Here's what we've got. From the top of the lighthouse, 156 feet above the surface of the water, the angle of depression of a boat is observed to be 28.7 degrees. Find the horizontal distance from the boat to the lighthouse. All right, so we've got a lighthouse here. I'll make a little tower. There's where the light is. And some guy is up here. He is 157 feet. 156 feet, sorry. 156 feet up from the surface of the water. There's our water. And we've got a boat out here someplace. That's right. I am really good at drawing stuff. All right, here's our little boat. And the angle of depression of the boat is observed to be 28.7 degrees. So we are looking down. And there's our straight across. And we've got an angle here. Our angle is 28.7. And what we want to find out is how far away the boat is. Well, which sides do we know? Well, we know this side. We know that's 156 feet, so we know the opposite side. And we know the angle here. What we are trying to find is the adjacent side. So we've got the opposite side, the angle, and we're looking for the adjacent. There's only one equation that has all that. That's the tangent here. It's going to give us the angle, the opposite side, and the adjacent side. We have to manipulate it around a little bit to come up with the opposite side now. Oh, I take that away. We have to manipulate around a little bit to come up with the adjacent side. So let's do that. If we say the tangent of theta equals opposite over adjacent, and we are trying to find the adjacent side, the side that is part of that angle there, we need to get the adjacent on a side by itself. Well, we can divide both sides by the opposite side. That'll cancel that. That gives us 1 over the adjacent. And if we want to invert that, we have to invert the other side as well. So we get the opposite over the tangent of theta equals the adjacent. Now, I've seen students work this a little bit differently, and I'll show you that too. Either way works just fine. So if we say the tangent of theta equals the opposite over adjacent, I've seen students say, let's multiply both sides times the adjacent. So that's going to basically cancel the adjacent off of here. And it's going to see the adjacent times the tangent equals opposite. Not really what we want. We want adjacent on a side by itself. So if we now divide both sides by the tangent, we end up with the opposite over the tangent of theta equals the adjacent. So it's just a couple of moves here different than what we did on this side. All right, so now that we have our formula, let's actually apply it. Our adjacent side we're trying to find, so we will look up the tangent of theta, and we're going to need the opposite. So the opposite side is 156 feet, and the tangent of theta is 28.7 degrees, And let's go to the tangent. We get 0.547. So I'm going to so let's take our 156 feet. That's our opposite. I'm going to divide by, and I'm going to use a parentheses here, the tangent. Oops, I'm going to put, I'm going to put our number in there. Sorry. So I'm going to say 156 feet divided by, let me clear this out, 156 feet divided by 28.7. I go to the tangent and hit equals. I get 284.9. We were given 3 significant figures in our problem, so that would be, the final answer would be 285 feet. So we should be 285 feet away from the tower. And we can go back and make sure that that actually works out right. Let's just go back and figure it the other way. So we're saying that the adjacent side is 285 feet. So let's take the opposite over the adjacent, and let's see if we can come back with that same angle again. So I'm going to do 156 divided by 285. That gives me a ratio of the two sides. Now when we got a ratio, I want to go to an angle. We go to the inverse tangent, and there is our angle again, 28.69, or rounded to 28.7. So I would say that 285 is an accurate distance for our ship. All right, let's try this one. So we've got a distance, and they're calling it P and Q, across the swamp. So let me draw our swamp out here. So there's our swamp. We've got P here. We've got Q over here. So the distance PQ across the swamp is there. So we want to find out what the distance is between that those two places. A line PR of length 59.3 meters is laid off at right angles of P and Q. So if this is, let's see if I can do this. So we need a line that's at right angles from that, from P and Q. We'll see what I can come up with here. All right, well, that looks like it's a right angle. Enough to give us an idea how to work the problem. Okay, so a line PR. So there's our point P, here's point R out here. Of length 59.3 meters is laid off. So there's 59.3 meters. Angle PRQ is measured at 47.6. So there's PRQ. So this, so P, R, and Q is measured at 47.6 degrees. So that angle right there is 47.6 degrees. And what we want to find is the distance from P and Q. All right, so we have two pieces of information. We have an angle, we have the adjacent side to the angle, and we want to find the opposite side of the angle. We know how to do these. It's going to be the opposite equals the tangent of theta times the adjacent. All right, so let's find the tangent of theta. And we know that that angle theta, 47.6, is going to be, we need to find the tangent, 1.09 or 1.1, and we're multiply that times 59.3, and that's going to give us 64.94, so 64.9. Oh, it's not feet, it's meters. Very good. All right, let's take a look at this one. The angle of elevation of the top of a building from a point on the ground 75 yards from its base is 28 degrees. All right, so we've got some building out here. There's my building. And we are 75 yards away at some point on the ground. It says from the base, so 75 yards from there to there. And they said this angle of elevation from the top of the building. So we are looking up to the top of the building, and it's 28 degrees. What we want to find is the height of the building. The height of the building is making the opposite side. So we need an equation that gives us the adjacent, the opposite, and an angle, and we of course have it with the tangent here. So we are trying to find the opposite, and we know that if we want to get the opposite on a side by itself, we can multiply both sides by the adjacent side. And so we've got the tangent of theta times the adjacent side equals the opposite side. And so we know we've got the tangent of theta, 28 degrees, and we want to get the tangent times the adjacent side, which we said was 75 yards, gives us 39.8 yards. We're going to have to round that up, so let's just call it 38.9 yards. All right. All right, guys, that's a wrap.